Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. Brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. We're very proud to have Dave Bird from Balluff today, where he is the industry manager for the metal forming and robotic welding industries. Welcome, Dave.
Thanks, Dean. I appreciate you having me on today.
It's great to have you here. It's great to have somebody with your background and knowledge of our industry to kind of talk to us about the future and what we're looking at. And in many ways, I know that people always have some similar problems to what they've always had, but it kind of has to always go back full circle, I think, in some ways. Please tell us a little bit about yourself and about Balluff.
Yeah, I'd be happy to. Balluff is a manufacturer of sensing, networking, connectivity products. It's really the nerve endings of a controls architecture within a manufacturing process, whatever that might be. Assembly and automation, in our case, in-die sensing, die protection. In the world of robotic welding, we have cells that indicate where parts are located before they're clamped together. They also require sensors to indicate clamp and unclamp positions to make sure we put the parts together correctly after they're stamped. And then we poke yoke certain features of parts that are critical to the fitment of a finished product after it arrives to customers' manufacturing location. So there's a lot going on there, and then we error-proof a lot of stuff. It's really critical, so we don't have scrap and waste and broken tooling and so on and so forth. So that's where I play. I'm on the plant floor almost every day. It's really kind of fun, actually. It's like toys for adults. Everything in these toolboxes that we have. It's like I'm a fisherman, so when you go fishing, you use application-specific terminal tackle, lures, and jigs, and so forth for the species you're going after. You know what? This is very much akin to looking in your tackle box and
Sure.
just knowing what works and knowing what to avoid. So Balluff is located in Stuttgart, Germany. We were started in the 1920s, believe it or not, making Spetzel machines and motorcycle parts, bicycle parts, major form of transportation in Europe. It's very interesting how it all evolved. And then we moved into very high mechanical switching trick dogs and cams, nitride hardened cams to monitor machining processes that are very rigorous with cutting fluids and chips and all that kind of stuff to within millionths of an inch accuracy when you're lapping and honing, chipping, grinding, and that sort of thing. And from there, it was really an evolutionary process. And as many know, the inductive proximity sensor was invented in Germany, and it evolved from that country. And they've become very reliable, and they're all application specific. I think that should be a theme today, Dean. Application specificity, putting the right things in the right locations to perform a very specific function. And it's where we fall down, either on the end user level or on the OEM level. We never, for whatever reason, seem to get the right things in the right spot, and that prevents problems for the people that are manufacturing things in high volume.
Well, speaking of that, what are some of the reasons you think we've had that difficulty, and what can we do about that? Taking a forward look 5 years ahead, what things can you see changing? Is it directly equipment, or is it almost an acceptance of it by management of how things need to be done and what we can do to achieve those goals? Do you think it's more equipment side, or is it more an understanding and education?
It's both. I would have to say we're in this, what you described as a distinct paradigm for both aspects. Just as in welding, I'm going to use the analogy of welding. When we're building a die, when we're building a tool to clamp and nest things together for welding, on the welding side, we have extremely high temperature bursts, thousands of degrees in some cases, plastic-faced inductive sensors for a general application on an assembly operation is nowhere near capable of handling the hostilities with weld BBs and all the other things that go with it, and even the leftover die lube from the parts that are often left in the welding cell that bake in that hot environment. So it's very interesting. And then and the die side, it's a very interesting world we play in because we have press manufacturers, we have tool and die makers. And then we have all the ancillary stuff that goes with it, the seating systems and all the other stuff. And then this other ancillary component is we have people who make dunnage parts and things that move parts from the manufacturer to the end customer that require a lot of monitoring and tracking, like RFID. It's amazing, but sometimes that twain never meets. PMA does a really good job of bringing people together in that world. I was very fortunate enough to attend the meeting in Tucson week before last. It was phenomenal. But it's evident, but we still have gaps. You know what I mean? This communication thing. We need to take a better look at what is it? What is the part? What is the components? What are we looking to put together? What are we looking to form, to stamp? And what are the rigors associated with the material? How is it going to be fed? What's the effect of punches and other tooling on that part that we're forming? All of that stuff. What do the lubes look like? Some of those lubes are extremely hostile. They actually deteriorate machine bed components and other things rather rapidly. Got to take all this into consideration, and it's got to plug into something. I still have end using customers in this country that they have equipment that it's around since the 20s and 30s. It's still functional. It still works, and they want to upgrade it, put sensors on things, but there's no press controls there. So we missed that vital component. What are we going to plug into, right? So it's a system. It's not, none of the stuff is out there on its own. So I think we could take for the future maybe a better holistic approach to this thing. And, you know, we're always reading about the Internet of Things and more this whole digital age thing. It's coming around in stamping, where we network things together and we do more monitoring of processes, especially companies that are multinational and they want to monitor processes globally. We need this stuff, but it's slow to come of age in stamping, but it's coming there. But it all starts with the very basic fundamental stuff. We have to have the peripheral stuff. We have to plug into our controls. The architecture has to be there. Everybody's ERP systems are different. But to take a more holistic approach to these. I threw a lot out there, Dino. Sorry, but it's what I face every day.
No, that's great. I agree that we have to take a more holistic approach, and it's a situation that we've often seen people start down a path and somebody else comes into a project and it never starts down that path again. It starts down a new path. And that's a challenge. From a hardware standpoint, it's a little less of an issue because the hardware's there already. But from a philosophical standpoint, what do we have to do? Is it more education? Is it focused where we have to focus more on training? Or do you think it's just basically a corporate situation where we really have to kind of get more people involved? Because I think sometimes we get to where we want to hand it off and just say, okay, now this is your problem, you deal with it.
Boy, that's a tremendous point. That's a bag of cats right there. But it's so true, Dean. It's all of the stuff. Education and training never ends. We should never be satisfied. It's good enough. And what's that old saying? Good enough seldom is.
Right.
It's never good enough, and we should always be striving for the highest level of nirvana, so to speak, that we can get. What does the ideal look like? And everything that we do should be working towards that ideal. But I see both. If you go to Europe, and you look at people coming up through the trades, and I know you've seen this, we talked about it. People are identified at an early age, kind of what's your skill set, what's your knowledge base, what are your interests, and that stuff. And there's a lot of apprentice programs that take place that are very, very successful, not only in the automotives, but in non-automotives, in scientific fields as well as in manufacturing. And these people live with this stuff, and they become extremely adept at what they do every day. I think that's a model we could look at, and and we're doing more at this PMA event, and in January it was very, very obvious that we're doing a lot of things. PMA is amazing what they're doing to bring up people through the ranks and spend money in education and bring people into the fold and get them trained and committed. We also had a section there that deals with the millennial generation. It's extremely good. But, the challenges in keeping that generation of folks involved is very, very important. It's the future of our business. And so we need to take their interests at heart and need to bring them up through the ranks. And it's a good, solid, honest way to make a living. It's got a lot of integrity. There's a lot of pride that goes with manufacturing. And I think those are things we need to do. The other thing is that we need to take a look at. There's so much going on here. Do we get into trouble a lot of times with programs, and then once we get out of trouble, it's manufacturing, we're running some tooling, something is causing issues, and there's ripples downstream. And as we all know, we get on the end user side, production takes precedence over everything. Got to get stuff out the door, or got to get it to the customer, and we kind of forget about a lot of things that we just drop it, we stop, and we don't go any further, we don't progress anymore. So we need to change that paradigm. We need to be striving for more, and I think even we, people who manufacture these products, will become more involved to help inform people and train. I do a lot of training on the plant level with new people coming in that are doing manufacturing. What does this stuff do? How do these different technologies work? Where do they fit? Where should we avoid certain technologies? Where should we lean towards certain technologies? What's proven? Where we had problems in the past? All of those things. It's all encompassing, but it can be done.
Yeah, and I think that's what we need to focus on, is the fact that it can be achieved. We need to have a focus on it, and we need to understand that one of the most important words in continuous improvement is continuous. That we're
I agree.
And we do. We need to keep working towards that, and that's where I think a lot of companies, continuous improvement is a journey, not a destination. And I think
so
that's
right.
an area that we have to. Yeah, and most manufacturers, I think, like to hand things off. The upper management likes to hand things off to the people on the floor and say, okay, this is yours, go deal with it. But we need to take a better approach. To give you an example, a lot of companies now have tried to switch from what we used to do, where we would kind of silo off our manufacturing. Every department was its own entity. You have your tool and die department, you have your press room department, you have your materials department. And the problem that Six Sigma somewhat created, I don't want to say it created it, because it's kind of what happened was, in my opinion, people started taking a distorted view of how they were using Six Sigma, and they would build metrics up to where each department had its own function, and that was it. And it ended clearly at this line. And we never found solutions because we were never looking for solutions. We were looking for, okay, it's not my problem anymore.
That's one of the fatal flaws, right?
Right. Do you think technology is going to play a bigger part in solving some of that?
Yes. Math doesn't lie. I just saw that movie Hidden Figures not too long ago, and that's a phenomenal movie from a lot of different aspects. But at the end of the day, when they were figuring out calculations for trajectory and propulsion and all these other facets of putting a man in space, the bottom line was math does not lie, and really. Technology doesn't lie. A lot of what these sensors are telling you, it's there. Do what you will with that data and that information. But, just like in the old days of whisker probes, I mean, you've been down this road, Dean. An employee could take a whisker probe and bend it, make it do whatever you want it to do, right?
Yep.
So that's lying. That's false information. But technology is going to give us more of hardcore data and the compilation of that data and storage of the data and this whole Internet of Things where we can monitor things more closely, often in real time. I'm working with a customer now in high-speed stamping, up to 1,500 strokes a minute. They're actually going to be able to monitor the shut height and look at variations during the high-speed process, making electronic components. But think about it, that's something you wouldn't be able to do just a few years ago. Technology didn't exist, but technology doesn't usually lie. Here's the data. Here's what the pattern looks like. The other part I wanted to tag on to what you mentioned, for any successful program to work and to make things be refined and perform fairly flawlessly. One thing I remember from one of George Karaminjev's programs, it stuck with me for decades, is for anything to work like this, you've got to have buy-in. It's got to become part of the fabric of an organization, whether it's the technology piece, the education piece, it's part of the philosophy and the fabric of the company. You've got to have buy-in from the corner office all the way down to the last operator. And the expectations have to be clearly stated, and there has to be accountability for things. And I don't mean being harsh about it, but we all have responsibilities, and we're going to live up to those responsibilities to have harmony in our company and to get things out the door, become a reputable, dependable supplier, period. And I think that just says everything. And Dean, how many times have you seen it where you don't have that buy-in, right?
Oh yeah. That's a challenge and it's true whether it's in automation, controls or safety. There's always a situation you run into where somebody doesn't believe in the program and they come out and they say, "Yeah, I know we are talking about doing this, but just go ahead and do it the way we've always done it. Don't worry about it. Just get it out." And sometimes, like you said earlier, that becomes part of the challenge is that production rules. And I'm not saying that we shouldn't, kind of follow that master to some extent, but we also need to have a realistic approach to say there's going to come a time to pay the piper on this.
Yes. And it's those companies. I wouldn't single anyone out. I'd be hung by my toes. But I work with customers, and you get the desperation calls. We're in deep trouble, and here's why. I have one. You're going to love this one. We're courting a customer for a long time in the state of Georgia, and really cool company making some really interesting stuff, not automotive related. But they're so busy and they can't get things out the door. And we're working with them. When are you going to get around to doing something to monitor some of the processes? The only thing that was on the press, many of the presses were safety light curtains and in a couple of cases a safety net for protection of the employee. And that's something, but nothing was monitored on these 500-ton presses. And all of a sudden, we had green operators that hadn't been properly trained, and again, no expectation, yada, yada, all the things. And the moon and the stars didn't line up the way they were supposed to that day, and you'll probably never see this again. But they broke the press. They cracked the crankshaft. They broke the tool. It was a mess. And not only did they have the damage in a wrecked press that actually had to be torched out and hauled out in segments in a very crowded, already busy, crowded factory with orders just through the roof. They had to buy a new press and figure out a way to get it installed in the same location. And I mean, a 500-ton press isn't moving a printing machine around,
Right.
And so now we're feverishly working towards helping them get something out to monitor the process to prevent this kind of thing from happening again. But why does it take catastrophe to prompt action? I see it all the time. It's just astonishing.
I think that some of that is that it takes a catastrophic incident to escalate to where everybody takes notice. I think that, unfortunately, that's where part of the problem lies, is that it has to escalate, that it's something that no longer can it be ignored. And
we humans are a strange breed, aren't we? No matter how well educated we are, where we come from, we always end up in these kind of boats at one time or another in our lives. But it's just unfortunate in these manufacturing environments that are very globally competitive on many fronts, that we do this. And the one thing I've learned from employees, talking with a wide range of people from all over North America, that one thing that frustrates people, one thing that turns employees over, are coming in every day and fixing the same problems. I've had people actually say, I quit. I'm going in another arena. I'm tired of coming in here and fixing the same thing and having the pressure of getting this whatever fixed to get the process running again, to get parts out the door. And it's so stressful that you go home exhausted every night. And I've seen it time and time again.
Mm-hmm. And that's true. There's almost, as the old saying goes, there's never time to do it right, but always time to do it over. And,
oh man, that's a good one. I hadn't heard that one, but it's really, really true.
It just seems to be that way, anyways. And it also works that way with money too.
That's true. And the problems always arise on Monday morning or Friday night when everybody's trying to go home.
Mm-hmm. Yep.
It's nuts.
I know. Hey, what? Tell me a little bit about what areas you see. Taking a look forward in about our 5-year perspective. What are some of the areas that we can look to try and solve one of the issues for people that don't own their dies? A lot of companies do stamping for other people, and without die ownership, how can we look to solve some of the in-die problems?
Oh, that's a $1 million loaded question, but it's a great one. One thing that is so big in any business, in any organization, that we all tend to drop the ball on is communication. I so often, I have die makers that don't know a sensor from a baseball bat. So why aren't we communicating? Why aren't we digging deep to get the communication together long before the die is built? What's going to come out the end of that die? What are we looking at? What kind of speeds are we running at? What kind of die loops are we using? What is it you're making, and what do we need to monitor? And the beautiful thing about new dies is it's easy. We can do it on the upfront. We can design it into the stuff. We can put tunnels in for cables and do all that great stuff beforehand. So much of my time is spent on retrofits.
Right.
And just like you've seen this a million times, there's customers with hundreds or thousands of different dies on shelves in the storage area. Somewhere they don't even know where they are half the time.
Mm-hmm.
So that communication to clearly state what it is we want to monitor and to pick the right stuff, get the communication going, bring everybody to the table that's involved in this. Your sensor supplier, your controls people, your tool and die people, and the most important thing, and I have to refer back to George Shermenchev. I learned a lot from that gentleman over the years. He's seen it all. The mechanical people know what's possible and what's not, and what a reality is of mechanics. Where is this stuff going to fit? How is it going to act? Where can we put stuff and where can't we? They're very, very important. The electrical piece is actually easy. Once we know what the signal is and the voltage and all that stuff and what we're monitoring, whether it's an analog signal or a discrete signal, we can do what we want to do with it and make it communicate appropriately. But that's the biggest piece that I see. And getting, I've been doing more of this in the last 4 or 5 years, is spending more time with die builders, die makers, to let them know what this stuff is and train their people. When that time comes, they're prepared for it, because they're getting asked to do a lot more of this stuff where it hasn't happened in the past. The biggest piece is communication and some training, and it's not hard. It's not hard to do, but we just don't get our arms around, again, part of that holistic approach. We don't get it done.
Right. Yeah. Well, we're just about out of time here. Dave, thank you so much for taking time out of your busy schedule to be here today. We'd like to thank all of our listeners for taking time out of their schedule to listen to this, hopefully on the road and being very careful as they're driving. From Longevity Industries and from the Precision Metal Forming Association, thank you for listening to the Destiny of Manufacturing podcast. I've been your host, Dean Phillips, and I'd like to thank you and have a great day.
Thank you.